Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. We just talked with Lynn Marks from Imperva about bad bots and how to deal with them. I'm your host, Mike Shima. I'm here still with John Kinsella, and it's just about time for the news. But first, save $100 on your RSA Conference 2022 full conference pass. RSA will be live in San Francisco June 6th through 9th. Security Weekly will be there in full force, delivering real-time live coverage and interviewing some of the event's top speakers and sponsors. Register with our discount code by visiting securityweekly.com/RSAC2022 and using the code 52UCyber. See you there. And finally, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to get all of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, chat with us on our Discord server right now, and follow us on our social media and our streaming platforms. And with those announcements out of the way, as usual, Mr. Kinsella, we have a lot of news to go through. Now, I don't quite have a theme, but I think we can pull one together. But one theme we are going to start off with is Wiz.io. The folks over there have been pretty busy. And I know you've been, I think it's safe to say, fans of their work, picking apart Azure as well as some of the other cloud providers. This one is finding a cross-account database vulnerability in Azure, specifically how Azure rolled out their version of Postgres, the managed version, if you will. And it was pretty interesting read through because it talks about the attacker mindset is part of it. In terms of just Wiz.io reasoning through, they have a goal in mind. We want to try to get cross-tenant attacks. So they ask themselves, how might we do this? And the reason I'm highlighting that is just that's one of those universal aspects that generalizes into threat models. And for any AppSec team can think about what they're looking at to think, what's our goal? And then how might we get there? And the other thing that I do have to talk about really quick is that one of the neat aspects of this is that they took advantage of regular expressions. And regular expressions notoriously, they fall apart when they're used as security controls because they aren't anchored, meaning they're not matching at the beginning all the way to the end of an input text, an input string. In this case, they were anchored. So they had little caret at the beginning, little $sign at the end. So that's the good aspect. But then unfortunately, the developers went and completely destroyed the end anchoring by just throwing a $* right at the very end, which says match anything. So rather than tying this, service-to-service authentication or identity verification to the common name within a certificate, looking at something like, this is your replication database with this identifier .azure.database.azure.com. It could continue on to be .azure.com. In this case, .wizresearch.com. And because the regex says, it looks like this common name in your certificate actually contains the host name that we were looking for, it will allow you to access it, even though the host name is actually just a subset of that pure FQDN that the researchers created themselves. So quite a clever and honestly simple use of bypassing identity and one of those mistakes in regular expressions. So that was my favorite part of this. I'm not sure if you've got a favorite part that might be a little bit different there, Mr. Kinsella.
I've got two of them. One, if you think about do I want to call it psychology? I'll say confidence. Near the beginning when they're, you hit upon it too, but when they're talking about how they decided to go and find this target and, after their previous research they worked on, actually, I mean, this, I don't know. I don't think an internal security team would go to this much trouble, but I mean, talk about a focused sort of, they're really coming up with like hypothesis they want to go after. So like they wanted a managed cloud provider that had some sort of dedicated virtual machine. They wanted some sort of service where they could execute code with the standard functionality and then hope to be able to escalate. And then they wanted the nature of the service to be high value. So that's off that three, that's where they decided to start looking at databases. But that's sort of a fairly sophisticated thing to do. To say, hey, we're not just going to, I think at least from my experience, a lot of threat teams out there, our research teams out there, just sort of, let's go and who have we not picked on for? Let's go look at them, right? And this is quite targeted, which I thought was interesting. But also the fact that they're describing how they came up with that target, to me, has a ring of confidence to it, right? That they're willing to say that out loud, that like, this is how we decided to find this. And that's a sign of a pretty mature research team, which I thought was pretty cool. Overall interesting. I mean, we saw something with Postgres in Amazon. I think we talked about last week in a show, or maybe a week before. So that was based off of a driver plugin. This is more core to how, as you said, how authentication was being used here. I thought it was interesting. It was 2 points on towards the end. They got $40,000 of a payout on this from the fine folks in Redmond. And then it sounds like this was ready to disclose 2 months ago. So why have they been sitting on it? I'm not sure if they're getting ready for conference season, or maybe that there's a little more to that disclosure path than what was shown in there, the timeline. But yeah, I mean, it's another good writer from the guys at Wiz. I think as you said, the regex is sort of the that's the thing for our listeners to think about it. Like how would you take that regex, which is there because you can see it on the page, and how would you craft that to, or how would you modify that, or the code that's using that to, not just react the way it did? Would you want to maybe not just, because I'm guessing what they had is I'm guessing they've got a URL and they're just trying to pull the host name out of it. So if they had just put a slash after that, would that have worked, or what could they have? Something could have been done there to make that more anchored, to use the phrase. But yeah, good write up for folks to think about and head scratching what happened over there and how can we make sure we don't do the same thing.
Indeed, and I think another thing, just on that topic of regular expressions, the other common way that they fail is dealing with input or mistaking input from being single line versus a multi-line match. So that's one of those other gotchas that can come up. So if you've got any regular expressions that are doing any type of controlling a security boundary, security control, make sure you've got some robust test cases around it. And there's sort of a partner. Oh, go ahead.
Well, what I was going to say is, as we were talking, again, I think it was last week, these blend together for me in a good way. But we were talking recently about it would be neat to see a library of tests that someone could download and run against your code. We were looking at it with, was that the database one? No, it was something else.
That was one of the crypto one, Witchproof, yes.
Yeah. But it'd be interesting in this case to see, maybe someone could have a collection of strings which you can download and unit test through your regexes. If you're trying to match a host name, it's a pretty standard thing, right? Okay, well, as you said, we got the example from here. We've got the multi-line one, like you said. These are type of things which they're I'll say known to us with air quotes for those in audio, from the point of view of we can, if you get a few of us and leave us in a room long enough, we'll think up a good collection of these, or we might have some already. But hell, throw that into an open source project and allow people to be able to get that list and actually test their applications with it. That could be sort of neat.
Would be. And speaking of testing too, there is one or two sentences in here about this PostgreSQL privilege escalation. And the researchers do mention that Azure had modified Postgres to, as they were describing, likely to introduce and harden the privilege model, possibly based on this, certificate validation, certificate identification between services. And it's not necessarily specific to Microsoft. So they don't say that they have identified this specifically in any of the other cloud service providers, but they were holding that part back too, in terms of the details on that particular part of the vulnerability, the exploit. So maybe we're going to see something more there. And that ties in a little bit, I think, to something we've talked before, also from the Wiz crowd, about what is a CVE-like system for cloud bugs. In this case, there was no action that users needed to do other than just be aware that if this vulnerability had existed. But there are things like the metadata service, IMDS v1 versus v2, which everybody should be using. It'd be good to have a CVE associated with that for AWS land so that people know this is a common misconfiguration here, or here's a common weakness in here that can be more easily exploited via SSRF. So I don't know exactly what that CVE-like system would look like or how different it would be, because in my mind, where is the call to action between what does a user need to do and respond to it versus here's just another list of CVEs to keep track of that vendors could say, yep, we check for the cloud CVEs. But that becomes just a lot of noise, perhaps. So, not sure where that can go.
So I had this thought over the weekend, and I have no idea what the hell I was working, but I don't know what I was working on that made me think of this. And I was going to turn into a Twitter thread, but I haven't yet. So hey, we'll put it here first and see what our listeners think. The idea of could you use Twitter as a sort of a vulnerability mesh or a vulnerability sort of not quite a neural network, but similar to a neural network from the point of view of, and this comes back to what we're talking about here with the cloud thing, but basically you've got a large collection of Twitter accounts that represent all these things which we could consume. So it could be NPM modules or languages or databases or cloud providers. And basically, they both have interconnections to each other, as well as me as a developer. I can actually go and subscribe to the ones I want. And then at some point, if say there's a vulnerability in Postgres or OpenSSL or one of those type of things, both it would ping, but then also the consumers of that would ping, and then I'd be able to see that ping as it would come to me. I don't know if there's something there or not, but it was a random thought that triggered sometime in my head this weekend. Yeah, so you've got a story coming up here. I don't know if you're segueing over to it, but we are now, of the cloud provider. I guess let's call it Cloud CV in general, the article from ThreatPost. And yeah, so we've covered this a little bit in the past. It's actually, I don't think it's too much different than CVE, but as you said, the particular use cases which stick out in my mind is how do you either recognize if you've been affected or not, your account? How do you recognize if you need to do a mitigation yourself or not? Because it's not like in this case, Microsoft took care of it. In a lot of cases, you can't. The cloud provider can't go and automatically fix something for you. Like if there's a default password, they can't just go and reset it because maybe you're using that for something else. They have to tell you to do that. So. Yeah, I know the CSA guys are still working on this. I'm sort of loosely watching it, but not too closely. It's getting traction and picking up, and that seems like something that good things will come out of it. So I believe they're working with NIST now. I'm trying to find a name I can Google. But yeah, for folks who are interested in listening on this, beside the ThreatPost article, if you go and Google CSA Cloud CVE or Cloud CVE database, it'll come up. There's a repo on GitHub with some of the work around it. And I think someone was recently asking, might be someone from CNCF actually, was asking if they could set up a sandbox so people could play with it. But it's got some interest and some traction, and it's still going. So hopefully that'll mature pretty quickly.
Indeed, and we'll see. And my final thought there is just hopefully we see lists that have something informative and useful to consume from, because we have lots of OWASP lists. I learned about the OWASP top 21 automated attacks. I got to go and refresh the OWASP site and be more familiarized myself with what they've got there. We also have a list, just a quick article I pulled from CISA about the top routinely exploited vulnerabilities from 2021. And quite honestly, I was just like, meh. I don't think there's anything interesting in here, but it seemed like since Sissa posted it, it was a list. We probably should just include it in the show notes. But it boils down to, are you exposed to Log4j? Are you running Exchange? Or are you running a VPN? If so, you probably had a bad 2021. And if not,
or a
you might
printer.
have had a bad 2021. Yeah, thank you, or a printer. Nothing from NPM made this list, even though we did cover a lot of NPM.
Isn't that
and
surprising?
honestly, there's many other there's a lot of other aspects here. But hey, there was a path traversal on the list, so I figured I'd mention it. But I think that's enough breath of mine that I think I wanted to spend on this one and jump to more interesting articles.
Briefly, one or two things. If I can stick my nose in there, it was a bit of a flashback for me. I mean, like when you look at the second table they've got in there, like the Celion and the sudo issue and the SonicWall and the Pulse Secure. Man, I know we talk about this a lot as a world, but like 2021 seems like so long ago and seems like it was so long, and like that just. You could have easily told me the Pulse Secure issue was 5 years ago, and I would have believed you. And that was like about a year ago, I think, right now. Yeah, that's all. The NPM one, I think that's actually really interesting. I hadn't thought about that when I looked at it. And now I'm going to go and look closer, but that's really surprising. I mean, I think they must be focused on packages more so than they are in modules, I think is what's going on there. So they might have to do a second list. But
yeah. Yeah, and these are the types of lists just to reinforce or say, we do need to invest in dealing with some of the legacy systems, areas that we haven't paid attention to perhaps in the past, or just say, why are we running our own exchange? Maybe we should outsource that or use a SaaS type of solution. But shifting to something more application defensive related, or for example, a call to change for developers, interesting plans out of Chrome to deprecate Document.domain. This is pretty cool, I think, because they're basically saying Document.domain, it's been mostly a way to relax, unfortunately, the same origin policy. There's a few design patterns that have emerged from front-end applications that are relying on Document.domain. But in the modern world of web application design, we've got better APIs to accommodate these types of design needs or programming needs. And so Chrome is basically saying, we're going to kill Document.domain. And by the way, we're going to explain why, and we're going to give you some alternative APIs for how to use post message, how to use channel messaging APIs to basically do the same types of to take advantage of the same types of workflows that you needed. So I think all told, this is a very positive thing because it says why it's a problem, what we're going to do about it, what you'll need to do about it, and it gives, rather than saying this is happening next week, they've got a nice long runway for you to be able to go and change your applications to accommodate it. So it will be a fingers crossed just to see how much traction this gets and how many applications actually change themselves, and if hopefully Safari, Firefox also follow along, which at the end of the Chrome blog, it does link to what the others are considering disabling this, or WebKit is moderatively positive about deprecating the Document.domain. So I also just loved that not very concrete or committed language, but let's be moderately positive about our application security, John. That's my takeaway.
I thought it was really, I think what was interesting about this to me is the maturity which we're seeing in not so much as AppSec, but specifically in the I don't say browser companies, browsers. There's a better word there, but like in these, these products which we have, well, particularly, obviously, I think I'd say numero uno would be Chrome, and Firefox does a good job of this too. It seems like we've hit a point of maturity where they are able to, with confidence, say, we've had enough of this, and we're now going to deprecate it. And we're giving you, like you said, some crazy period of time, which isn't necessary because it sounds like this isn't really heavily used. But just the fact that you're able to sort of go, with confidence, because I think in a previous, few years ago, we would have been like, shoot, that's like, a core part of your DOM. How can you do anything? You're not going to be able to fix that, right? It's like everyone's using it. But now we've done it a few times now, and there's been the bumps in the night, and people sort of figure out how to do it, that they're able to say, yeah, no, we've had enough of that. And I think that's pretty great. And that's I think that's probably a heavier statement than it sounds like if you think about it. If we were to do that within our own companies, even me with a fairly young code base, if I go to deprecate something which is fairly core, I can do it, and I do it. But at the same time, it's like it's how do you do that in a larger code base or in like something as popular and public as this? You have to. It's not easily as done as it sounds like. So I think kudos on that from that point of view.
So I'm also now going to bring in another article not from a security newsletter, but from PyCon. So Python had a conference over the weekend, and there was a really interesting and curious presentation on what is it called? PyScript. So this is basically a way to embed Python within HTML that turns into a front-end web page of WebAssembly. So it's a Python to WebAssembly compilation pipeline that is pretty interesting for a couple of reasons. To me, one of the aspects is, where are the security panels, the security presentations at these developer conferences? So this is more of a kind of a call out to our listener population that, yes, there are plenty of B-sides, there's plenty of great security conferences to attend to, and there are good reasons to present at them. But if you want to make a lot of changes, and especially if you have a language-specific type of presentation or topic to cover, go find one of the developer conferences and speak at something like a Python conference, or pick your other favorite language. They've all got them. And because that's really the crowd that you want to talk to. So that's one little sandbox aside. But the other thing here is really neat to see a use of WebAssembly that is this is a data science perspective that the company behind this is creating this for, built on a lot of open source capabilities, and script in this other Pyodide Python package that I wasn't familiar with. But it's interesting. It will be interesting just to see what developers want to do and the capabilities they're pulling into the browser to start where we'll start seeing WebAssembly. And on the one hand, it's good that it's sandbox. It's good that we've got it to be able. It's neat to see it compiled down into WebAssembly. But it will be interesting to see what types of attacks emerge from that. Meaning, are we less about there's going to be there may still be sandbox escapes, where my mind is more going is just how much data are we going to start pushing into the front end, or how much data are we going to start moving around between systems? And that's where user identity, service to service identity, like we saw in the Postgres example, becomes really important. So I don't think there's a problem necessarily directly with this. It's a little bit of a that's interesting, just to put your Python right into your HTML, but something to watch out for, something to keep an eye on for sure.
It is interesting. So we were talking again last few weeks about the costs, both time and resource wise, of moving data around. So you got an interesting point there to think about. I'm guessing they're going to be doing smaller testing in the browser than when they want to do the heavy crunch and to send it to something a little more powerful, but I don't know, maybe not. You've got systems now like this, the new Mac Studio, that like you got crazy performance locally, right? So do you need to use the cloud for doing your training and testing of your algorithms? Maybe not. I have to say that the first thing that really hit me in this article, I was cringing a little bit because I saw this. I'm like, oh no, please don't be compiling to JavaScript. Please don't be compiling to JavaScript. And I hadn't actually figured out yet. I either the word did miss me when I was reading through it. I guess there it is, like halfway down. But then when you said WASM, that somehow has a more positive connotation to me. I'm like, oh, WASM, okay, that's interesting. But I think what you said is accurate in that over the next 24 months or so, as WASM starts becoming more popular, I bet we're going to start seeing some class of security issue with that. We're starting to see some cracks, tiny bit of cracks in some of the Rust stuff. So I suspect we're going to start seeing it here too. And people, it's basically you go rest on the laurels. I mean, like they say here, it stands on the shoulder of giants, sits on the shoulder of giants. But like that's not always a good thing, right? It's you still needs to check your regexes and do all these other things. And there's something else we have in here. Oh yeah, something caught my eye, the Thinkst part about defensive coding. And like you still have to do these things. So it'll be interesting to see how this affects that. My sense is it's becoming easy enough to do this now to compiling to WASM that we're going to see more folks doing this with different things out there. Can you use it in different scripting connotations, or how it will be used? It's one of those things like as it's out there, people start playing with it, we'll see how it gets used. So that's going to be sort of neat. Yeah, anyways.
Yeah, and so listeners, if you have some favorite WebAssembly resources, let us know. Or if you've done even some research yourself, or you've come across some research, please highlight it for us. Because one other thing that comes to my mind is just things to worry about are secrets management, and how will we just get into some obfuscated approaches to putting keys, for example, into these identity as we get more and more front-end facing, or I think it's called edge computing is the current term of art for this types of applications. How is WebAssembly handling secrets? Because secrets are what we use and what we need for encryption, for identity, things like that. So I think lots of really neat stuff to research, and a lot of really neat things that could be fruitful for presentations. Another thing that's fruitful for presentations, at least I'm trying to make it happen, is fuzzing. So just a quick reference to this, another article on improving the state of GoFuzz. It's a neat walkthrough that just gives a little bit of background on the Go fuzzer itself, and some feedback on how to make fuzzing more effective against the types of applications that people write. Because it's one thing just to say, yes, we're going to fuzz all of our systems. It's another thing to say, the fuzzer actually understands something like SQL. It understands HTTP 1, HTTP 2, HTTP 3 now, for that matter, and is able to do more interesting types of mucking about with the state machine to find vulnerabilities. And that's really why we need the fuzzing, is to understand the applications rather than just to say we're going to burn a whole bunch of CPU time and hope that we find some vaults. So I wanted to highlight that real quick, but nothing too deep. A good read, but I didn't want to spend too much time on that because you did allude to a Thinkst article there, John, that I wanted to get to. So let's go to that one. There is another neat quarterly write-up from, or quarterly summary that Thinkst Canary, the Thinkst that they put together, called their Thinkscape, that's really just look back at the quarter of what were the various security presentations that were presented across the spectrum of application security, hardware, and just general InfoSec. There's one really neat one that stood out to me about secure coding and the benefits of it, but let me, I'll save, I've been talking for a bit. John, were there certain ones that you had a chance to at least get some interesting, that looked interesting from the titles that you wanted to touch on real quick? Yeah,
I wish I'd made some notes on this. So let's see, I'm going to go from the bottom up. And the first one, actually, I just happened to catch, this is what I was just talking about. So Synology was at a Pone conference. Is this the big Chinese one? I think it is in 2021. And they didn't get pwned. And the reason why, what this particular article goes through, is like how they've actually gone through and done a bunch of defensive coding in the development of that application. And why that is of particular interest is a Synology device is basically an IoT thing, right? It is sort of, I mean, it's heavier than that. I know they're in data centers, but it's a fairly lightweight NAS. So being able to have that level of AppSec focus on a tool like that, or an application like that, a package like that, is it's a great sign of maturity. So I thought that was pretty cool. Let me see if I can pick out one or two more. Some of the ML stuff was interesting. Adversarial watermarking to minimize deepfaking. We've already talked about post-quantum cryptography, so I'll skip on that. The confidential computing is okay. Didn't really excite me too much. I think that's sort of it's a complicated space. The Hyper-V fuzzer I thought was interesting. From not so much fuzzing Hyper-V, but the devices around it. So, we were just talking about fuzzing the other article, but now how do you, how you do that on a larger scale? Not so much an application, but like think about if you're trying to figure out, weaknesses in KVM and Zen and things like this. And we're always making jokes about the, the floppy driver, and that's where the bug's going to be, or the USB driver in your VM. So they're doing a spin on that for Hyper-V. I thought that was interesting. How about you? Anything catch your eye?
Yeah, the Synology one was actually the big one that stood out to me, because I also like the spirit of the presentation in the sense that it is talking about, it has some good feedback about what was working from the defensive perspective. And there's one of the points they're making that adding new features doesn't necessarily have to expand your attack surface, because that attack surface is sort of that magic phrase that the attacker-minded thinking are looking for. When we had that callback, we'll have a callback to the ExtraReplica, the Wiz.io folks looking at where's the attack surface that's out there. And we have one other last article too from Microsoft about Nimbuspwn that was, again, just what is the attack surface about the IPC message bus within Linux. So that was really neat to me, that it was giving some positive feedback. And I'd also encourage anyone to click through on that, the slides for that, because the two researchers behind it have some great resources on just fuzzing in general and how they go and look for, and I try to identify vulnerabilities. So if you're interested in reverse engineering in this type of research, they have some great resources. So there's definitely a good path to follow down just from that single one. And so that's why, for me, I wanted to highlight the Synology one.
And the one other I'd feel remiss if I didn't mention was the AMD branch mispredictor, where no CPU has gone before. If nothing else, just for the title is sort of amazing, right? But it is sort of interesting. And, again, these are sort of those the more meaty, heavier kernel hacking type things, but there's a few good ones in here. I mean, this is always a fun list when they come out with this. I don't think I ever got through all the articles from the last quarterly, and I'll have to try harder with this one to actually not just read the summary, but go through them in depth. So that'll keep me busy for a while.
Keep you busy, yes. And definitely attacking JavaScript engines is another one that's near and dear to my heart, that's possibly on the good topic here for our AppSec folks. And I did mention, I want to just squeeze in a real quick chat about the Nimbuspwn vulnerability. I don't know that this is a vulnerability or a handful of vulnerabilities that Microsoft discovered within Linux's dbus. Don't know necessarily that it's going to be a super pervasive, all hands on deck type of vuln to go fix, because I'm going to guess that the local privilege escalation might be a dime a dozen, or maybe with a dime every 20, depending on the inflation, but still relatively common. But did want to highlight this because it shows a really neat attacker mindset, in the sense of they were doing some code review, some dynamic testing of dbus, because they're like, oh, look, here is a system passes around messages between a bunch of applications, a bunch of programs, that some of which run as root. And obviously, if it runs as root, that's a good target for us. So they basically said, how can we get ourselves to execute with root privileges? And they went through some fun directory traversal, did appear in here, some race conditions, time of check, time of use, where they swapped out some symlinks, and eventually we were able to execute a program of their own and be able to launch essentially a shell as root. So really neat walkthrough. If you also are unfamiliar with or less familiar with a lot of kernel basics, this is also just a great way to walk through and touch on a lot of common kernel or Linux principles, from directories handling to symlinks to race conditions to shell execution, sbin, bin directories. So it's also a really good kind of educational article, I think. So that's the other reason I wanted to highlight it. But I've exhausted, I think, what I find, what I was wanted to describe there. So anything left over for you, John, to extract from that article, or something else that we might not have touched on?
Oh, I knew when I saw this one last week, and I saw ... I'm like, oh, Mike's going to cover this. Not really. I think some of the diagrams are interesting to actually show visually for those of us like what's actually going on something like this. It's I think as you said at the top, it's another, at least to me, it's another time of use type vulnerability. I think it's going to be interesting to see. So I can't, what distro word is this on? Don't know if it mentions. So as and where I want to go with this is as some of the Linux distributors are working on new and funky things, like both like how does Linux work in a container or in Kubernetes or in a virtual machine, or how do we do modernized package managing? In particular, I'm thinking of Ubuntu Snap. Where you're going to see dbus is still there, but there's other things which are doing fairly powerful, weird stuff in the system. So I think we're going to start seeing some interesting things from other angles. Because there's no doubt in my mind that those things are not 100% secure. They're too new and too complex. So there's something there. This is interesting. I mean, dbus has been around for a while, right? So why hasn't someone poked at this a little bit sooner? Maybe they haven't. They just didn't have the right combination of folks or meals or whatever to actually figure out stuff. But yeah, it's a decent write-up. It's, sort of, I think between, if you bookend what we started and finished with here, if we're finishing with this, starting with the Wiz research, and sort of going through how they did their stuff and their thought process about what they were doing, and then here with the Microsoft Defender guys, what they're doing at the end. I think that gives folks some pretty good homework to sort of think about what they're doing, how you would go through that. And this one, I think I looked last week. The patches are out everywhere, right? There must be. They wouldn't publish otherwise. I believe
so. Yeah, and I think one of them was like he was talking about Linux Mint or some of the less common.
You're right.
I think we'll say about some of the distros. So that's why, the focus for me was more about the approach and the thought process rather than the impact, if you will.
Yeah. But anyways, the reason I was mentioning that is go and find yourself a vulnerable system or create a vulnerable container or VM or what have you, and poke and hack at it and see if you can reproduce what they're doing here, and that's hell, even for me that's sometimes fun. So that's I'll let people go with that.
Yep, set up in your lab. And it also was one of those race conditions that looked actually pretty easy to trigger. I think they only needed 3, less than 10 iterations runs in order to get that race condition to pop correctly, which is good and makes it a lot easier from an educational perspective, a learning perspective, as opposed to other race conditions where you might have to just peg that CPU, sit back for an hour until you get the magic, PID mismatch or PID pop over, something like that. Anyway, those were not PID popover is by no means a technical term. It's just something that I made up, but it sounds delicious. And with that, I think it sounds like we probably better wrap up here before I start making up more application security terms. So let me just say thank you to everyone out there who's listening. Thank you everybody who was hanging out on Discord with us. Thank you, of course, to John for walking us through a lot of these articles. And please subscribe, give us a like, check out the show notes. And speaking of robots, check out Robot Lover by Vandal Moon. And with that, we'll see you next week on Application Security Weekly.